So tomorrow we have a quiz. The quiz is going to cover 5-1 to 5-5. There are going to be 17 questions. Now, technically, there's not really anything from 5-1. That is actually where we learned how to find a greatest common factor or factor integers. So it wasn't really until we hit 5-2 where we actually started using that. So, for example, on the first question, it's going to say, find the GCF. And you're going to get a question that'll say something like 42, AB squared, C to the third, and then 30, A to the third, B squared, C. And it's going to say, find the GCF of these two. So again, you're going to look at the number part, and you can either do the list method, or you can do the tree in order to find the greatest common factor. So if I did 42 and 30 and I did a tree, 6 and 7, 5 and 6, it doesn't matter what you start with. Just remember, you're going to keep breaking it down until it's prime. And then remember, you're going to look for the ones in common, and you notice how they both have, the only thing they have in common is 2 times 3. So then you would look for the smallest exponent, so it'd just be 2 times 3. So between 42 and 30, the greatest common factor is 6. And then for the variable part, you're going to go back and take the smallest of the letters they have in common. They both have A's, but I picked the smaller one. They both have B's, and I picked the smaller one. This was the same, so it's just B squared. Then I go back, they both have C's, and I picked the smallest. So my greatest common factor here is 6AB squared C. You're also going to get a question that's going to say to simplify this fraction. So let's say it's 32 over 44. The fastest way is to find the greatest common factor. My GCF here is 4. So if I divide them both by 4, I get 8 over 11. You're going to get another one where it's going to say to simplify, but it'll have variables with it. So let's say I have negative 6p to the third over 12p to the fifth. When I reduce the 6 over 12, I get negative 1/2. And then the exponents I'm going to subtract. And I'm left with a negative 2. So I put the negative in the denominator. Then you're going to get another one with more than just one letter. Let's say I give you 39 x to the third y squared z divided by 52 x squared y. So I need to reduce my 39 over 52. I can divide them both by 13, and that'll give me 3 over 4. And now I'm going to simplify the x's, simplify the y's, and nothing, so the z is just going to stay. So I'll subtract the x's, and I get an x to the first. Subtract the y's, and I get a y to the first. And then there's nothing to subtract with the z, so I just write it in the top. The next one is actually going to say to divide. So if I give you 10y minus 5 over 5, remember we're going to divide 10y by 5 and negative 5 by 5. And it's going to leave us with 2y minus 1. Then it's not going to actually say divide, it's just going to say simplify. Number 6, same thing. But instead of a binomial, it'll be a trinomial. So 14x minus 28y plus 21z divided by 7. Again, divide all 3 by that 7. So then final answer here is going to be 2x minus 4y plus 3z. Then number 7 is going to say factor. So you're going to get a question that says something like 4x plus 18. So again, the instructions for 7 through 9 are all going to say factor. So here I'm going to look for a greatest common factor between 4x and 18. And that greatest common factor will be 2. So I'll divide them both by 2. And then you write the GCF on the outside, and then the answer to the division in the parentheses. Now you're going to also get one with 2 letters, where you are going to pull out a GCF that is going to be involving a variable. So 4y squared plus 8y. We can see my GCF here is going to be 4y. You write the GCF, divide, and that's what goes in the parentheses, the answer to the division. Number 9, same thing, but now it'll be a trinomial. So for example, you might get 14p to the third q to the third minus 21p squared q squared plus 35pq. So again, I'm going to look for my greatest common factor. And between 14, 21, and 35, it's going to be 7. And then notice they all have p's. And I picked the smallest, which is just the plain old p. They all have q's. And again, I picked the smallest. So I'm going to divide all 3 by 7pq. So 7pq goes outside, and then the answer to the division inside. And you're done. So that is 7 through 9. Then you will get one question from 5-4 where you're just going to have to FOIL it. So for example, if I say it's going to say multiply. So if I give you 3r plus 1 times r minus 2, all you're doing is FOILing. So first, outside, inside, and last, group your middle terms, and you're done. The last 7 questions, numbers 11 through 17, all come from 5-5. So you're going to get some basic ones where it's just going to already be the difference of 2 squares. So let's say this is 1. 1 is a perfect square. So the first thing you should do when you see this is double check that this is a perfect square, this is a perfect square, and that this is a subtraction sign. So I would break this into 2x minus 1, 2x plus 1. Another example could be 16x squared minus 9. Again, check. Make sure all 3 conditions are met, that these are perfect squares, and that this is a subtraction sign. So then this would factor into what number times itself is 4x, and what number times itself gives you 9, which would be 3 and 3. One's a plus, one's a minus. Yes? No, it does not. So you can do it either way. Now, also remember, you might get a question where you're going to have to factor a GCF out first. So let's say you have 2a to the 4th minus 18a squared. Always look for a GCF first, because notice these aren't perfect squares. But if I divide them by its greatest common factor, which is going to be 2a squared, then I get the difference of 2 squares that I can actually factor. So then 2a squared, a plus 3, a minus 3. And again, the order of the plus minus does not matter. You will also again get the question where, like I just did, where, for example, I would pay close attention to numbers, let's see here, questions numbers 55 through 56. Okay, so make sure you're paying attention and doing 53 through 56. You will get one of those. It will be very difficult. Now, also remember that if you get a question like this, 4x squared plus 1, there is no such thing as the sum of two squares. This can't be factored. However, if you get a question like this, let's say, good morning. Okay, so let's say I get something like this, 16x squared plus 100. First glance, you're going to say, oh, wait a minute. Those are both perfect squares, but it's a sum and I can't. But what could we divide both of those numbers by? By 4. So we can actually factor this by just dividing both of them by the GCF, which will be 4x squared plus 25. Then you would stop at this point because you can't divide them by anything else. Okay, so quiz tomorrow, 17 questions, 7 of them come from tonight's homework. So make sure you're paying close attention to this homework tonight. You only have to do the evens, but if you're struggling with those evens, I would definitely go back and do the odds.